Hello everyone, welcome to this new video. So in our previous videos we have solved many problems related to star delta transformation. So this would be one last session related to star delta transformation. Three different kinds of problems I have got to you all, and we are going to solve those three problems. Okay. So those who have not seen my previous videos related to star delta, and also we have solved some of the problems related to source transformation and source shifting. It is available in my playlist. Please go and check it out and share that and like this video before you watch this video. Okay. So let's start with the problem. So this is the fifth problem again. Same thing again, between these two terminals A and B. This is the complex circuit they have given. We should be reducing this circuit into between that in such a way that between these two terminals you should be having one single resistance. Okay. So this is the circuit. You should be applying the star delta transformation here. So this is some kind of, we can say that some kind of a critical problem. Till now we have solved the problems. Those were of very easy, and we could recognize wherever the delta and star connections are there. But in these kind of problems, there will be some complications. But still, if you try to analyze the circuit and recognize it, it would be easy. So this is here the first circuit. Analyze it. You can see that here we have one star connection, right? So now for that we should be finding the equivalent delta connection, that is this triangle. So this is one star connection, or we can call it as a T connection. I told you star network can be also called as T network. Okay. So for this now we should be finding the equivalent delta. Okay, that is, see, I have drawn the dotted lines. We should be finding these three values here. Okay, the three resistances here, and you should be replacing this by the delta connection. Okay, you know how to convert star to delta. The formula is, to convert star to delta, we should be considered, in order to find this value, we should be considering the opposite two resistances, that is here in this case it is 3 ohms and 2 ohms. So what we should be doing, 3 plus 2 plus the product, that is 3 into 2 divided by the remaining resistance 5. Okay, that is equal to 5 plus 6 by 5, right? And if you solve this, you would be getting 5 plus 6 by 5 is 1.2. Okay, so this is 6.2. So this value is 6.2. Similarly, you should be finding these two values as well. Okay, first let's find that value, then I'll write the circuit. Okay, so let's find this resistance here. For that, again consider the two opposite resistance, that is 5 and 2, and the product of them 5 into 2 divided by 3, that is 7 plus 10 by 3. Okay, so that is equal to 7 plus 3.33, and that we will be getting it as 10.33. Okay, 10 by 3 is 3.33, right? Similarly, for third connection we have this value, that is, you should be considering the two opposite resistance, 3 plus 5 plus 3 into 5 divided by 2, that is 8 plus 15 by 2, that is 8 plus 15 by 2 is 7.5, and here we would be getting our answer as 15.5. So these are the three resistances. So now let's write the equivalent circuit here. So like this we have written here the circuit. This star connection or T connection was there. I have replaced it by this delta connection, and all the rest of other components I have kept it as it is. Okay. So here now we can see that these two branches here meet at one common point. In order to make this simple, we can split this point and we can write these points here, so that these two would be in parallel, these two would be in parallel. We can convert it to one equivalent resistance, right? So now let's write that simplified branch. Yeah, see, I have written it like this in order to make the complications easier. So now these two are in parallel. We should be converting to one single equivalent resistance. Okay, that is, first is 5 into 6.2 divided by 5 plus 6.2, right? That if we solve this, we will be getting around 0.247. Okay, you can check it later. And for this we have 10.33 into 4 divided by 10.33 plus 4. And if we solve this, we would be getting around 2.88. Okay, you can check it later. Now write the equivalent circuit, that is, here we would be having one single resistance. So this 15.5 6 ohm, 4 ohm, I'll keep it as it is. Here we would be having single resistance. This is A, B. So here the value is 0.247 ohms. So here we have 2.88 ohms. 6 ohms, 4 ohms, 15.5. So I've written. Now what we should be doing is, this connection, if you observe carefully, this is here in the pi connection here. Okay. So here we can again convert this to equivalent T connection like this. Okay. That is, you should be converting delta to star again. So again the same procedure, delta to star. I told you how to find the values for delta to star. Okay, this resistance, this and this, three of them. First you should be considering for here the opposite resistances are 6 and 15.5. Okay. So try to so here, from here you should be considering the star connection, that is this way. Okay. These three values you should be finding now. That is, first value is this value, that is, we should be finding the opposite resistances in this case, in when the resistor is here, are 6 and 15.5. That is 6 plus 15.5 plus 6 into 15.5 divided by 4. Okay, if you solve this you would be getting around 3.647. Okay. Similarly, for this resistances, the opposite two resistance are 6 and 4. 6 plus 4 plus 6 into 4 divided by 15.5. The value here we will be getting around 0.941. You can check it later. Okay. Next is for this resistance. These two are the opposite, that is 15.5 plus 4 plus 15.5 into 4 divided by 6. And if we solve this, we would be getting around 2.43 ohms. Okay. Like this we have solved it, and try to write the equivalent circuit here. That is, this is the required T connection. And rest of the two values keep it as it is, 0.247, 2.88. So here we have 3.647. Here we have 0.941. Here we have 2.43. Okay. So this is the reduced circuit. Now what to do here is, as you can see that here these two these two are two different branches. These two are in series. These two are in series. Add them so that here two resistances would be in parallel. Again find its equivalent resistance, and finally that would be in series with this resistance. Okay. So like that we should be solving. See, I have reduced it here. I have added these two, 3.647 plus 0.247, we would be getting 3.894. 2.43 plus 2.88, we would be getting 5.31. Now these two are in parallel, so that's why into 5.31 divided by 3.894 plus 5.31. If you solve this, you will be getting around 2.24. Okay, you can check it later. If you solve this in the calc, if you put it, you would be getting 2.24. Now reduce the circuit again. 0.941, 2.24, A, B. Finally these two are in series, that is 0.941 plus 2.24, we would be getting around 3.18 ohms. So that would be our final value of resistance between the terminals A and B, that is 3.18 ohms. Okay, so like this you should be solving this problem. So we have two more problems, let us solve those. So this is the next problem here. This is one diamond shape here we have like this. So this is a bit of straightforward but a little bit confusing. So here again these kind of similar problem we have solved, where we have told that we had two delta connections if you observe it, but actually we have only one in that problem. But in this problem here, if you observe it, you might be telling that we are having 4 delta connections, so you should be converting all 4 delta to star. But no, it's not the case, because these all 4 are interconnected, and if you check carefully, there are only 2 delta connection. That is, this is 1 delta, this is 2 delta, or we can consider this as 1 delta and this as 2 delta, anything, either this and this or this and this, the opposites, and rest of the 2 resistances keep it as it is. So here what I'll do is, you can take either these 2 and you can convert from delta to star, or you can take these 2. So I would be taking these 2. Okay, these 2 converted to delta to star, the values of these 3 you should be finding. Okay, first I'll write the reduced circuit here after delta to star. Okay, then I'll find the values. Okay, so like this I've reduced here. If you observe carefully, this delta I've converted it to star, and this delta I've converted it to star, and these 2 resistances I've kept it as it is. See, so that's why this figure has become a bit tilted. So here the values of these 3 and these 3 resistances are, so here we have 12, 12, 12, 12, 12, 12. So if you do once, we can say that all the values are same. Delta to star, we know the formula, that is 12 into 12 divided by the sum of all the 3, 12 plus 12 plus 12. 12 12s are 144 divided by 12, 12 12 is 36. Okay, 36 ones are 36, 4s are 144. Our answer is 4 ohm for all the values. Okay, since the all the value resistances are same, so we would be getting 4 ohm. Now if you observe carefully here, these 2 resistors here, 8 ohm and 4 ohm, are in series. They are in one single branch here. Okay, similarly these 2 resistors are in series, and here inside these 2 resistors are in series, but these 2 are individual connections. So how we can reduce and write the circuit like this? See, so I have reduced it like this, where this resistance is here, these 2 are in series, so this is 12 ohm, 8 ohm plus 4 ohm is 12 ohm. Similarly, this opposite resistance is 8 ohm plus 4 ohm is 12 ohm, 4 ohm is 8 ohm here inside, and here this 4 ohm and this 4 ohm I've kept it as it is. Okay, so like this I've reduced this circuit here now. So now again we have one single delta connection converted to equivalent star. Okay, find these 3 values. First, this value, that is the 2 opposite resistances are 4 and 12. So 4 into 12 divided by 4 plus 12 plus 8. That is 12 4s are 48 divided by 12 plus 8, 20, 24. That is 2 ohms. Okay, so this value is 2 ohms. So this resistance 12 and 8, 12 into 8 divided by again 24, that is 8 1s are 8 3s are 3 1s are 3 4s are, so this is 4 ohms. So this value is 4 ohm, and this value is 4 into 8 divided by 24. Again 4 1s are 4, 6 are 2 4s are 2 3s are, 4 by 3 is 1.33 ohms. Okay, so now let's reduce the circuit here, convert it to equivalent star. This 12 ohm and 4 ohm, keep it as it is. So this value here is 2 ohms. This is 1.33 ohms. This is 4 ohm. This is 12 ohm, 4 ohm. Now we can see that these 2 and these 2 are in series. Okay, so that's why our reduced circuit would be looking like this. This is 2 ohm as it is. 1.33 plus 12, that is 13.33 ohm. 4 plus 4 is 8 ohm. Finally these 2 are in parallel. That is 13.33 into 8 divided by 13.33 plus 8. If we solve this, we would be getting around 4.99 ohms, or we can round it off and say it as 5 ohms. So this is 5 ohms. So finally 2 ohm plus 5 ohm is equal to 7 ohms. So this is our final answer. You can check this answer later, okay? So like this you should be solving this problem. Very easy. Hope you understood the steps. So we have one more final problem. Let's solve it. So here till now we have solved problem where all the circuit consisted of all the resistances, right? So in this one problem we have one voltage source here, and in the problem they have asked us to find the current through this circuit. Okay, we should be finding the current through this circuit using star delta transformation only. Okay, that's one change here. So that's why they have given here voltage source. So we should be keeping this voltage source till the end of the step. Along with that we should be having, we know that whenever we have voltage source, the resistance would be in series. Okay, this voltage source we should not be touching, keep it till the end, and rest all the components here, use star delta transformation and reduce it to one single resistance. Then finally use the formula I is equal to V by R and find the current. Okay, so here again this is in delta here, so convert it to equivalent star. Okay, you should be finding these three values. First I'll write the equivalent circuit. So here I've converted this to star here. Actually it is T. So if you tilt this and bend this point till this line, then we can say that this is T connection. Okay, that is this value and this are the same. This and this are the same. This and this are the same. Rest 2 9 ohm I've kept it as it is. So now let's find the equivalent T connection. Delta to star, how to follow, that is already I know. This value, opposite resistances, and 3 into 3 divided by the sum of all 3 plus 9. That is 3 3s are 9, 9, 12, 15. 9 by 15 we would be getting around 0.6. Okay, so this value here is 0.6 ohm. Similarly this value, that is this resistance, these two are the opposite. 3 into 9 divided by 15, 3 1s are 3 5s are 9 by 5, we would be getting around 1.8 ohms. So this is 1.8. So finally these two are the opposite. 3 into 9 divided by 15, again we would be getting 1.8 only, right? So this is again 1.8. So like this we have solved. Now nothing much. Now we have here like this, here this one branch, here we have one series branch. Okay, these two are in series, and similarly these two are in series. So that's why what this circuit would be looking now, 24 volt, 9 plus 1.8, here I'll write it individually as 10.8 ohm. So here we have 0.6 ohm, again 9 plus 1.8 is again 10.8, like this, right? So now finally these two converted to the parallel, so converted to a single equivalent resistance, that is 10.8 into 10.8 divided by 10.8 plus 10.8. Okay, that is equal to, since these two values are the same, and whenever, one more trick is, whenever we are doing resistors in parallel, whenever we have the same value of resistances, we can directly divide the resistance by 2. That is 10.8 by 2, that is equal to 5.4. So that is now 24 volt, 0.6 ohm, 5.4 ohm. Finally these two are in series, that's why we would be getting this as 5.4 plus 0.6 is 6 ohm, and this is 24 volt. So we have one voltage source and one resistance. So finally I is equal to V by R, 24 by 6, that is 6 1s are 6 4s are. So that is our current value is I is equal to 4 amps. Okay, so like this way we should be solving this problem. Hope this is clear. And that's all for this session, guys. We have wind up the topic star delta transformation, and from the next session we are going to start with the very important concept and very easy. If you know one law, that is Kirchhoff's voltage law, that concept would be very easier, and some of the equations you should be putting in the calculator and be solving. That concept name is mesh analysis or loop analysis. Let's see that concept in the next video. Like, share, subscribe to our channel, spread this playlist to a huge number, and especially for those backlog students, so please try to cover this subject within this backlog and don't carry forward the backlog. Okay, so that's all. Thank you.